Well, hello, fourth grade math teachers. Welcome back to another Prep Talk video where we get you ready for your PLCs the week of September 26th so that you are ready to go to teach the content to your students on October 3rd. As always, we'll take a look at some of the teaching strategies that we'll use to convey the information to students and look at some of the star-released questions that you'll want to consider whenever planning your lessons. So as we take a look at the weekly overview, a couple of things to notice. We are finishing up multiplication of 4-digit by 1-digit numbers using the standard algorithm, and then moving into 2-digit by 2-digit numbers using several different strategies in order to help students conceptualize the idea of how to do this. Also, you'll see that on Friday we have a flex day for DCP testing. More than likely, your campus is not testing on Friday. They may be testing on Monday or Tuesday. And so whatever day your campus is testing, obviously plug that flex day into that day and adjust your schedule as necessary. You'll see the 3 TEKs for the week are down below. 4H we've been working on for quite a while. That's just a reminder that the multiplication that we're doing usually needs to be in the context of a real world 1 or 2-step problem. 4C is going to have students representing the product of two 2-digit numbers using a variety of methods, including perfect squares through 15 by 15. And 4D is going to have students solving real-world problems using strategies and algorithms to multiply either a 4-digit by a 1-digit number or a 2-digit by a 2-digit number. We've already looked at this star-released question in a previous Prep Talk video, but I wanted to bring it back now that we're talking about the standard algorithm. An orchestra had 8 performances. There were 2,464 tickets sold for each performance. We want to know the total number of tickets sold for all 8 performances. This is a great opportunity for your students to do a turn and talk where they have to discuss which operation they will use in order to solve this problem. Notice that this is never done in a vacuum. It's always done in a real-world contextual way. And so students have to be able to solve problems in order to answer questions correctly. Once they land on multiplication and give you a reason why, you can have them set this up using the standard algorithm. 2,464 multiplied by 8. Then you can have students connect this back to some of the strategies that we have previously used, including partial products, so that they can hopefully think through how that relates to the standard algorithm. Another thing is that you'll want them thinking through reasonableness and estimations. Notice that we're multiplying a number with a 2 in the thousands place by 8. That means at the very least, our answer is going to be 16,000. Well, if you'll notice, there are 2 answer choices that are way off base here. And so hopefully by thinking through the reasonableness of our answer, we won't have any friends choose answer B or answer C. Then we go through the process using the standard algorithm. 4 times 8 is going to give us 32, and we will carry the 3 into the tens place. Then multiplying 8 times 6, or 6 times 8, will give us 48, adding the 3 that was carried over from the ones place. And so 48 plus 3 will be 51. We'll put the 1 in the tens place and carry the 5 into the 100s place. Then 4 times 8 again will give us 32, plus the 5 will give us 37. We'll put the 7 in the hundreds place, and then we will move on to the thousands place, carrying over the 3. 2 times 8 is 16, plus the 3 is going to give us 19, for an answer of 19,712. As we move into talking about the product of 2-digit numbers, the Math and Practice script on page 103 through 105 could not be any better. This lines it up perfectly for you as the teacher to explain how we use an area model in order to determine the product of 2-digit numbers. I'm going to try my best to just illustrate this for you in real time so that you can see how it works. I have a piece of grid paper here, and I have counted out a 24 by 15 grid so that I can use it to determine the product of 15 times 24. Now, I want to decompose these two numbers into two nice parts. So for 24, I'm going to decompose that into 20 and 4. And so I'm going to block this off into two different parts of 20 and 4. Then for 15, I'm going to do the same thing, and I'm going to block that off into 10 and 5. And so if we count up 5 squares here on the bottom, that would put us here, so that when we draw this across, we will have 10 squares above that horizontal line and 5 below. Then, when we set this up, we're just going to be doing 4 partial products of finding area in order to find 15 times 24. And so for this big rectangle, we will be doing 10 times 20, which we know is going to give us 200. For this rectangle over here, we will be doing 10 times 4, which we know is going to give us 40. For this rectangle down below, we'll be doing 5 times 20, which we know will give us 100. And then finally, 5 times 4, which will give us 20. And so adding up the area of all 4 of those rectangles will give us the product of 15 times 24. And so we will have 200 plus 100 plus 40 plus 20, making sure to line up our place values, and this will give us 360 as the result. Again, the script on page 103 through 105 in your math and practice book for 4th grade gives you questions that you can ask students to help guide them along in this thinking. And really, if you follow that script, you can't go wrong with this particular lesson. This question has a similar idea. I want to find the product of 11 times 13. You'll notice that on the top, I have broken up 13 into 2 nice parts, 10 and 3. And on the side, I've broken up 11 into 2 nice parts, 10 and 1. From here, students will be able to visualize using base 10 blocks what is going on in the multiplication. When I multiply 10 times 10, I get 100. When I multiply 10 times 1, that's what I get when I have this right here. That's going to give me 10. Then 10 times 3 is what happens when I multiply these 3 things together here and add them together, and so that's going to give me 30. And then finally, the 3 ones will come whenever I have these leftovers down here. And so 1 times 3 will give us 3. Adding all of those numbers together will give us the result of 143 when we multiply 11 times 13. Students have to see this visually so that they can make those connections to the standard algorithm when we get there for multiplying 2 two-digit numbers together. Let's look at this star-released question for 4.4c. We want to know which model represents that product that we just did on the previous slide. Well, what you're going to notice is that if students are able to at least set up their model by decomposing the 2-digit number into nice parts, they're going to get this question correct. And so if you look at letter G, that is the only one that decomposed 13 and 11 into 2 nice parts. F is sort of confusing. They didn't have a top and a left-hand side. Here in H, they have 11, but then they have 3. They don't actually have 13. And J is probably the best wrong answer, but all they had was 11 times 11. They did not have 13 times 11. And so noticing here that G is the correct answer because it correctly decomposed that 2-digit number into a tens place and a ones place. This released question is very similar. We want the model that represents 14 times 14, and so that would be one of those perfect squares that the TEK mentions. Again, you'll notice that there's only one answer choice that has taken 14 and decomposed it into a 10 and a ones place. Well, that would be letter H, which is the correct answer here. Letter F would be modeling 4 times 14. Letter G would be modeling 7 times 2. And letter J would be modeling 14 times 1. None of those are 14 times 14, as H is the only one that has the correct model. What we notice in this star-released question is that students must be able to go from an array or an area model to an equation. And so what you'll notice is that students will have to count up how many circles there are on the top of this array and how many circles are on the side of this array to know what equation that array represents. Counting on the top will get them 14, and on the side will get them 13. So they should know that this array is modeling 13 times 14, which is letter J. One misconception or error that students could probably fall into is not counting this as both on the top and on the side. So make sure that they are counting that right there as both a top piece and a side piece. We account for this released item in our curriculum resources by looking at area models. And so students would have to count the number of squares that they see on top, the number of squares that they see on the side, so that they could write the equation or expression and then actually be able to multiply it using the area model. In this star-released question, 27 teams are in a hockey league and there are 16 players on each team. We want to know how many players are in the hockey league. Students need to recognize once again that they are multiplying here in order to get the result. We are multiplying two two-digit numbers together, 27 and 16. We need to break apart these two numbers into a tens and a ones piece so that we can use an area model or the idea of partial products in order to find their product. For 27, we can break that into 20 and 7. And so drawing a line down this way to separate those two parts, I can show that that is 27. Then on the left side, I'll have 16, which can be broken up into a 10 and a 6. Then I can draw a line across so that we are able to break this into 4 partial products. For the first partial product, we will have the following: 10 times 20, which will give us 200. Then we will multiply in the top right-hand corner 10 times 7, which will give us 70. In the bottom left, we will have 6 times 20. 6 times 2 we know is 12, but we're not really multiplying by a 2. We're multiplying by 2 tens, and so that's going to give us a result of 120. Finally, in the bottom right, we're multiplying our two ones places together, which would be 6 times 7, which will give us 42. Then we want to add together all of those partial products. Make sure that students are lining up their place values correctly whenever they write these numbers down. In the ones place, we will have a 2. That automatically eliminates G as a possibility. In the tens place, 7 plus 2 is 9, plus 4 is 13, so we will carry the 1 into the hundreds place. That eliminates F as a possibility. And finally, we have 1 plus 2 plus 1, which will give us 4. And so 432 is the correct answer. If anything in this video caused you to have a question, or as you're looking through the other star-released questions, if a question pops up, please feel free to visit our office hours virtually Tuesday, September the 27th from 3:30 until 4. You can come and ask your question, get help on whatever you need through the pre-planning process as you get ready to teach the content for the week of October 3rd. And as always, before you go, please fill out our survey using the QR code to the left or the link provided so that we can know that you watched the video, and your feedback will help us serve you better in future videos. Thank you again so much, 4th grade teachers, and we wish you the best of luck as you plan in your PLCs for the week of October 3rd.